This video is to take you through a problem on what Q is and how it all works. So let's take a look at the problem. At 44 degrees Celsius, the equilibrium constant for the reaction is 50.5. Is this reaction at equilibrium? That's my first question part. And then if not, which direction must it proceed to reach equilibrium if we start with this and this and this? Now I do notice it says the starting part, but it doesn't say it comes to equilibrium. So this is not an ice table problem, because it doesn't start with it, which I have, and then give me an equilibrium number of some kind later on. So that's how I know it's not an ice table. I'm questioning, is this reaction at equilibrium? So this is where I'm going to write the Q. In this case, it's given me moles, so I know I need the QC, the concentrations. Now Q stands for question. So I'm not writing the K because I don't actually know, is this at equilibrium? And K means equilibrium expression, or the equilibrium value. Now I'm questioning if this is equilibrium, so we use the Q value. So when you write the Q, it's actually the same as writing the K. So let's write the Q for this reaction. It is of the concentration, so I'm going to use the brackets. Products is HI, squared on top because of that 2 there, divided by my reactants, H2 on the bottom, times my I2. So now what it's giving me is values. So it's saying like this could be the equilibrium values or it might not be. So I'm going to plug them in and see if it does actually equal my K. Because I don't know if that equals at 50.5. So I really don't want to include that in there because I don't even know if it's at equilibrium. Okay, so they gave me that I'm starting with HI of 2.0 times 10 to the negative 2. But that's in moles, so we got to be careful about that. So I got 2.0 times 10 to the negative 2, and that's moles. And these brackets mean molarity. So I have to do moles per liter, and they tell me it's a 2-liter container. That's an easy way for AP to get the people caught on who understands what these things mean and who's just plugging in numbers and just doing like patterns. So this is to kind of separate those two groups of people. So you be in the good group and know that, oh, I saw moles, I got to divide by my liters to get my actual molarity. All these gases are in one big bucket, so their liters is the same. It's just the number of moles inside that bucket are different. So there I put 2.0 10 to the negative 2 moles per 2 liters on top for my HI, divided by, again, it's going to be in 2 liters, and my moles of H2 are that 1.0 10 to the negative 2. And then the concentration of that 2.0 liters on the bottom, and 3 times 10 to the negative 2. So at this point, I'm going to just boop, 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 push it all in my calculator, and I get a number of 1.3. Now again, this has no units because I actually solved for Q. Q is very similar to K. I just didn't know if it was equilibrium or not, so there are no units on this one. So I got 1.3. That's my Q. Now my K is actually equal to 50.5. So I can clearly see that these two are not equal to each other. My Q does not equal my K. My K actually happens to be much greater than my Q. So the first question is this at equilibrium? No, it is not. If not, which direction must the reaction proceed? In other words, when I look at this equation, my K is really big and my Q is small. My K value of 50.5 means it's really product favored. Q also means it's product favored, but not quite so much, right? If I thought of it that way. So what this means is if I have 1.3, I've got some products, but not as much as my K value has. I need to shift the reaction to make more products. In other words, to get my Q, 1.3, closer to my K value, I need to get this upper value on top to be a bigger number. If I can get this value on top to be a bigger number, it'll get closer to that 50 number. So this means it'll proceed to make more of that HI. And HI happens to be a product, so that would say I'm going to proceed to make products in order to get my Q value closer to my K value. Let's kind of simplify this down. If your Q equals your K, that means you're at equilibrium. If your Q value is less than K, which is like we had just right here, that means I've got to get more products to get it to equal to K. So I'm going to make more products. If my Q happens to be greater than K, that means I've got too much on the top of my fraction, so I've got to make more of the bottom part of my fraction. In other words, I've got to make more reactants until it'll reach equilibrium. That would be your summary for that. I hope it helped.